Good morning. Myself Nijeesha, Assistant Professor of Computer Science Department in Emmanuel Arsat JJ College of Engineering, Nattalam. Now I am going to teach about addressing modes in a subject Computer Organization and Architecture. First we have to discuss about addressing mode. What is addressing mode? So addressing modes or techniques used by the CPU to identify the location of an operand needed for executing an instruction. They provide rules for interpreting the address field in the instruction, helping the CPU fetch operands correctly. Which means the addressing mode means the CPU identify the location of an operand in an instruction. It is called as addressing mode. Then we have to know about opcode. What is opcode? Opcode means operation code. This operation code is the part of a machine language instruction and that tells the CPU what operation to perform. What operation going to perform. For example, ADD R1, R2 means ADD is the opcode. ADD means it tells the CPU to perform addition. If SUB means subtraction. MUL na multiplication. Likewise, the opcodes are the CPU to perform some addition or subtraction or multiplication or move the data. DIV means division, ANT means logical AND, OR means logical OR, JMB means jump to another location. But in simple words, we know opcode means what to do. What to do in the CPU, that is called as opcode. Next is operand. An operand means the data or addresses on which the operation is performed, which means an operand is the data or location of data on which the instruction operates. For example, ADD R1, R2 means here ADD is opcode, which tells the CPU what to do. And R1, R2 means that is operands. Tell the CPU what data to use. That is called as operands. Okay. Next, the types of addressing mode. Addressing mode types. Common addressing mode types are immediate addressing, register addressing, direct addressing, indirect addressing, register indirect addressing, indexed addressing, base addressing, relative addressing, implied addressing. These are the 9 types of addressing modes. One by one we will do. Okay, first is implicit addressing. Implicit is also called as implied addressing. In implied addressing, the instruction does not mention the operand directly. The instruction does not mention the operand directly. The CPU knows what to use from the instruction itself. Usually a special registers like accumulator or the stack. This is the implicit addressing. Or in simple words, in implicit addressing, it is an addressing mode in which the operand is automatically understood by the CPU and does not need to be explicitly specified in the instruction. That means operand is implied by the instruction itself. For example, CMA. CMA means complement accumulator. This accumulator is the implicit operand. No operand is written in the instruction. So operand is understood automatically. This is called as implicit addressing. In immediate addressing, the operand is the part of instruction itself and it is used when the value is known while writing the program. In immediate addressing, for example, if move R1, #5, it moves the value 5 into register R1 where #5 is the immediate value, which means in the immediate addressing is an addressing mode where the actual operand value is directly given in the instruction. Here the actual operand value is 25. This is the immediate operand and the opcode is MOV move and R1 is the destination, that is a register. Here the CPU directly uses the value 25 and it does not need to find 25 in memory. This is called as immediate addressing. Okay. Here the actual value is given directly in the instruction. So So the value is immediately available. This is called as immediate addressing. Okay. Next is direct addressing. Direct addressing means the instruction contains the memory address of the operand. The CPU accesses the data directly from the address. Here the example is load R1, 1000. It loads data from memory address 1000 into register R1. In this direct addressing, it is an addressing mode where the memory address of the operand is directly given in this instruction. For example, if load R1, 1000 means here load is the opcode and R1 is destination register and 1000 is the memory address and memory address that containing the operand. So the CPU goes directly to the memory location 5000 to get the data. Okay, the instruction contains the actual memory address of the operand. So the address is given directly. This is called as direct addressing. Okay, next type is indirect addressing. In this indirect addressing, it contains the address of the memory location, which itself stores the actual address of the operand. The CPU first accesses the memory location to get the effective address and then fetches the operand. That means here, for example, load R1, A. It loads data from the memory location where address is stored at memory location A. Here load is opcode and R1 is, it contains, R1 not A. A contains the address of the data. Here A contains the address of the data and data at that address operand copied into R1. That operand is copied into R1. Okay. For example, if A is equal to 5000, so memory 5000 equal to one value. So that value is called as indirect addressing. So load R1, A loads data from the memory location where address is stored at memory location A. If A has some memory value and directly go to that memory, in this memory it has an operand value B, then go to operand, directly go to, so they indirectly go to operand is called as indirect addressing. Here the instruction gives an address that points to another address. One instruction, one address points to another address where the operand is stored. Okay, which is address to address, then goes to data. This is called as indirect addressing. Next is register addressing. In this, the operand is located in a CPU register specified by the instruction. What are the steps means? The instruction first specifies a register R. The CPU takes operand directly from register R. Here, register addressing is an addressing mode where the operand is stored in the CPU register. For example, add R1, R2. Here, add is opcode. R1 and R2 are operands stored in where? Registers. The CPU performs the addition using the value in these registers. For example, R1 equal to 10, R2 equal to 20. After add R1, it stores the value in R1 equal to, answer is 30. Okay. So operand is stored directly in the CPU register. Data is inside the register is called as register addressing. Okay, next type is register indirect addressing. In this register, it's specified in the instruction contains memory address of the operand, which means the steps are: the instruction specifies the register holds the memory address. The CPU accesses that memory location to fetch operand, which means this register indirect addressing is an addressing mode where a register contains the memory address. The register contains a memory address of the operand. For example, move R1, R2. Here R2 equal to 5000 memory address. The R2 contains the memory address. Memory address is 5000 and it has a data 25. So this is the actual data is 25. Then the instruction load 25 into the register R1. Here this register contains the address, not the actual data, only contains the address. This is a register. So here address to data, this is a register indirect addressing. But in register addressing directly goes to data, register to data, this is register addressing. But in this register indirect addressing, the register go to address, then address goes to the data. This is called as register indirect addressing. Okay. Next is displacement addressing. This displacement addressing is also called as in-text addressing or base register or relative address. In this operand, effective address is calculated by adding a constant value. Constant means this is called as displacement to the content of one or more registers. In this, the instruction provide a base register R and address part A. CPU add the value of R and A to get the effective operand address, and operand is fetched from the calculate address in memory. For example, used for arrays accessing an element at the position relative to a base. Here, displacement addressing is an addressing mode where the effective address is calculated by adding a register value. Register value, that means a base address and a fixed offset. It is displacement. By using this, effective address equal to register plus displacement. For example, if move R1, 20, that is R2. If R2 has address value base address 1000, this is called as base address 1000, and 20 is the displacement or offset. So here the effective address is 1000 plus 20, totally 1020. So the CPU get the data from memory location 1020 and puts it in R1. Okay, so here addition, add, that is effective address, one formula, effective address equal to register plus displacement, that is the memory value. So 1000 plus 20 is 1020. This is the displacement addressing. Put in the register R1. So this is called as effective address. Next, the final addressing modes are stack addressing. In this, the operand is implicitly taken from the top of the stack. Without being mentioned in the instruction, the operation is performed using the value at the top of the stack, that is implied by instruction. No need for explicit operand field. CPU refers to stock pointer register by default. For example, pop and push operations. Here, stack addressing is an addressing mode where the operand is stored on the stack, and the CPU use the stack pointer to access it. The stack follows last in first out, that is LIFO, last in first out. For example, push 25 and pop R1. Here, push 25 means that places 25 on the stack value 25, and pop R1 means it removes the top value from the stack and puts in R1. Removes the top value from the stack and put in the R1. Here the stack pointer keeps trapped at the top of the stack. This is called a stack pointer. Here in the stack addressing, the operand is accessed through the stack by using stack pointer. The stack is last in first out, that means top element is accessed first. This is called as stack addressing. Okay, that's all about addressing modes. Thank you.